All right, Mrs. Teasley here. Today we're going to talk about linear and absolute value inequalities. First thing we'll talk about is the union and intersection of two sets. So the union symbol, which looks like a U, is the set of all elements that are numbers or members of A or B or both. All right, so union is A, B, or both. So you're adding them all together. The intersection, which is this upside down U, is a set of all elements that are members of both A and B. All right. The one that we're going to use the most will be the union symbol. But let's just see how this actually looks. Like, what does a union symbol represent? What does the intersection represent? All right. So how does this stuff work? So you have two different sets, A and B. They want us to determine the union of A and B. So the union of A and B will be everything that's in A, B, or both. So I start off with writing down the 1, 2, 3 from A. Then when I get over here to B, notice that I have a 2 already listed, so I don't have to write down 2 again. But I need to add to this list 4 and 6. All right, so that's the union. The union is the numbers that basically, if you put them all together and, don't write down any numbers more than once, this is the set that you get. That's the union. The intersection is what numbers or what members they call it, what elements or members are in both sets. So when it comes down to intersection, when you look at the first one, I have a 1, 2, 3, and I have 2, 4, 6. Because the 2 pops up into both A and B, the intersection of A and B would just be the number 2. All right, so based on what I just said, pause the video, try example 2. All right, let's look at example 2. So I have two sets, B and C. They want me to determine the union first. So the union would be everything that's in B. So 2, 4, 6. And you don't have to worry about writing this symbol, the set symbol. In my math lab, they already have that there for you. All you have to do is just type in the numbers. All right, so if you're having a hard time writing it. But 2, 4, 6. And then I'm going to go over here to C and write down numbers that are in C. 1, 3, 5. So the union would be all of those numbers together. The intersection, what numbers do I see in both sets B and C? Well, there's no number that's in both B and C. So this is what we call the empty set. And another notation for the empty set, what you're going to see it written as is a circle with a line through it. Not a 0, but that's the empty set symbol. All right, the empty set. All right, so letter D, they talk about, they want you to find the numbers, the union and the intersection of D and E. So how does this look? So for D, if you draw a number line, you have, well, actually, let me just draw one number line. All right. So I have a number line. All right, X falls between 0 and 4. So what I'm going to do is I'm going to shade between 0 and 4. 0 and 4, that's going to represent this D inequality. Then E would be numbers from 2 to 6. Well, where's 2 located? Let's do it. Let's do 2 would be here. And let's say 6 is over here. So let me use a different color to represent E. So for E, I'm going to do this yellow. Might need to do a little bit darker, so let's see green. So when they ask you, where's D union E? D union E would be anywhere you see shading. Well, I see shading between 0 and 6, all the way from 0 to 6. So in this case, this is called set builder notation. So what they have listed here is set builder notation. So the answer for D union E would be the set of all x such that, so that bar, and again, you don't even have to type that stuff in. The only thing you have to type in is the inequality part. So since I see shading from 0 to 6, then 0 less than x less than 6. That's the intersection. That's the union, I'm sorry. Union is where all the shading is located. I have shading from 0 all the way to 6. So that's how I write that in set builder notation. Set builder notation is the little squiggly lines, the fancy symbols. And then D intersect E. Intersect is where do you see the shading overlap? Well, the shading overlaps here. I see green and pink between 2 and 4. So the intersection would be the set of all x such that x falls between 2 and 4. All right. So I mentioned set builder notation. We need to talk about interval notation. So interval notation, we're going to be using interval notation to write most of our solutions in this section. All right. So let me kind of scroll through. I want to make sure that okay. So interval notation. This chart, this box right here, I'm going to be referring back to. So I'm going to highlight this box. So, this is a nice little chart that we can use. All right, but I'll kind of explain it as I'm going along. One thing you want to know is that anytime you have a less than symbol or just a greater than symbol, we're going to be using parentheses. If it has a less than symbol and equal to, so less than or equal to, or greater than or equal to, we use brackets. All right, anytime you see infinity or negative infinity, we're going to also use parentheses. So you'll see what that means in a moment. All right, so let's look at this example here. So first of all, let's just use this chart to write our sets in interval notation. So here we have a number, we have this -3. Let me highlight it. I have -3 less than or equal to x less than 5. If you go here and you look up here and you find the chart that has it listed in this form. Let me see if they even have one. So here they have a number with a less than or equal to symbol, and then they have that less than number. So this is how your answer look. All right, so if you wanted to use this chart, then this would be a bracket. A in our case would be -3, B would be 5 with a parentheses. So -3, 5. Then if you look at the next one, part B, so we're just going to use this chart, and I'm going to show you how you can get around, not using this chart. So 7 less than or equal to x, 7 less than x, which is less than or equal to 10. So if I look up here, the chart that has a less than and a less than equal to symbol, all right, here in green, you write the answer in that form. You have an A and a B, a parentheses around A, so parentheses around 7, comma 10, bracket B. All right, let's go reverse, the opposite way. I have a 3, 8. Well, if you have two commas, if you have two parentheses with a comma in the middle, then your answer is going to look like this. So if I write this in set builder notation, this would be the set of all x such that x falls between 3 and 8. All right, and then the last one, I have a problem where I have two bracket symbols. So let's use a different color. So here in blue, -2 to 5. So here, those are the less than or equal to symbols between behind both numbers. So in this case, it would be the set of all x such that -2 less than or equal to x less than or equal to 5. All right, So if you're a person who like to use a nice little chart and something to refer to, then this chart would be helpful. All right, this will probably be the only time I use this chart, but I just want you to see how to use it. Same thing for here. Now we have another chart that's dealing with unbounded intervals. So here, this is another chart. So, like I said, if you're a chart type of person and you like to have formulas and something to look back to check your answers or to match up your answer, then this would be something nice to have like on your cheat sheet. All right, so write down. So they want me to write this in interval notation. So I have x is greater than or equal to -2. All right, so greater than or equal to -2. So if you look over here, that looks something like this, where you have x greater than or equal to a, which a could be any number. So what they have is they have a bracket. I will write down our number, which is -2, comma, infinity, with the parentheses. And then the other one is x is less than -2. So I will go over here. All right, I have a less than symbol. X is less than a number. So my answer should look like this. So it would be -infinity, comma, b. B in this case is going to be -2, and it has a parentheses around it. All right, again, those charts are helpful just to write numbers in interval notation. I will not be using this chart. I'm going to use what I told you here, which is about the parentheses and the brackets. All right, so it's probably going to take some green with it, but that's fine. All right, let's see. So you don't have to worry about doing examples 7, 8, or 9. Let's get down to the meat of the lesson, which are just solving inequalities. So solving inequalities is just like solving an equation. The only difference is that if you divide, all right, so if I divide or multiply by a negative, you must flip the symbol. All right, so if you get down to that final step where you have to divide both sides by a number, if it happens to be a negative number, you need to flip the symbol. All right, so let's look at the first one. So example 10. All right, and I'm going to show you how all this comes together. So now I'm solving this inequality. So to solve this inequality, you want to get x on the left side. So what you do, I'm going to add 7 to both sides. So 3x is less than 12. Then I'm going to come back and divide both sides by 3. So this is x is less than 4. This first answer is your set builder notation answer. So set builder is going to be the set of all x such that x is less than 4. All right, so that's the set builder notation. Let's talk about interval notation. But with interval notation, we're going to do our graphing first. So to graph an inequality, the only number you care about is the number that you have listed in your solution, which is 4. This says that x is less than 4. So I'll look at it as my less than symbol, all right, which looks like an L. If you open it up, it's an L. But also look at the fact that it's pointing. So if you look at this as an arrowhead, it's pointing to the left. So I'm going to shade in this direction to the left. Even I'm shading this arrow down here at the end. You have a number line. Your number line goes from -infinity to +infinity. That's what those arrows represent. Now, if you remember anything about inequalities before in a previous class, when we start graphing, we have to put open and closed circles. But when it comes down to us using less than, well, in this class, when we use less than or greater than symbols, we're going to always use parentheses. So what you want to do is you want to close off your shading. So what I'm going to do is I'm going to draw, I need to close off this shading. So I turn my parentheses this way to close off this orange stuff. And then I can even put another imaginary parentheses down here, because remember, you want to close off the shading. This is your graph. Interval notation is a short version of your graph. So notice how when I use, maybe I shouldn't put that line there. When I talk about if I'm having less than or greater than symbol, I use parentheses. All right, so notice at the 4, there's a parentheses. Also, whenever I use infinity or negative infinity, I have to also use parentheses. So that's why I put a parentheses all the way down the end. Now, why do I need that parentheses? Because when it asks me for interval notation, so interval notation, interval notation is just a short version of this graph. So the first thing I see down here is I see a parentheses. So I put parentheses. All right, I have a negative infinity. Then that orange stuff, I'm going to represent the shading, the orange stuff with the comma. So that orange stuff is the comma. And I'm shading to what number? I'm shading to 4. And I put my parentheses. So if you were to like take out all the shading and replace that shading with a comma, your graph will look something like this. And this is your interval notation answer. This parentheses, it replaces the open circles. So if you did inequalities before, you had open circles and closed circles. Now we use parentheses and brackets. All right, let's try this next example. All right, the next example here, same thing I want to solve. And when you're solving these inequalities, you're going to have to do all 3 things. You're going to have to find the set builder notation, the graph, and interval notation. All right, so here, let's solve this for x. I'm going to add 7 to both sides. Negative 2x less than or equal to 19 plus 7 is 26. Then I'm going to come back and divide both sides. In this case, I have to divide both sides by negative 2. So because I'm dividing by a negative 2, that means my symbol needs to flip and turn, and it becomes a greater than or equal to symbol. All right, so 26 divided by negative 2 is negative 13. If I put all my little fancy stuff around it, which, you know, you don't have to, this is your set builder notation. Then I'm going to graph this. All right, so when you graph, the only number you care about is negative 13. Infinity, when negative infinity goes down here, this is infinity. Your symbol is pointing to the right, so you shade out here to the right, including the arrow. Now you have to block off your shading. Because this is a greater than or equal to symbol, if you go up here to the chart, anytime you see a greater than or equal to symbol or less than or equal to symbol, we use brackets. All right, it just depends on which way you need to turn it. In this case, I'm going to put a bracket and turn it this way because I'm closing off my shading. Remember, there's an imaginary parentheses down there around infinity. So when I write my answer, interval notation is a short version of this graph. So I'm going to write down my bracket. I'm going to write down negative 13. I'm going to write down a comma that represents the shading. I'm going to write down infinity because that's what's next, and a parentheses. So what I'm doing is, instead of me using that chart or that table above, I'm using my graph to help me write my answer in interval notation. And you have to know how to graph it regardless. So it's helpful or it's useful to know that the interval notation is just a short version of the graph. All right. All right, moving on, let's look at example 12. All right, example 12. When you see problems like this, you want to keep your x in the middle. All right, so my goal is to solve for x, to isolate the x. I'm going to isolate the x in the middle. So I want to get x by itself. So first thing I want to do is I want to get rid of that minus 3. Well, to get rid of minus 3, you need to add 3. But you can't just add 3 to the middle. You have to add 3 to both sides also. So all 3 places you have to add a 3. 1 plus 3 is 4. Less than 4x, because the 3's will cancel out. Less than or equal to 14. Then I come back. I want to get x by itself, so I need to divide by 4. All 3 numbers I divide by 4. 4 divided by 4 is 1. less than, 4's cancel out, x less than or equal to. If you simplify 14 over 4, what number can I divide into both 14 and 4? The answer would be 2. 2 goes into 14 7 times. 2 goes into 4 twice. This is my answer. This is the set builder notation, so I can put my little squiggly stuff around it. So that's set builder. When it comes to graphing it, the only two numbers you care about are 1 and 7 over 2. So 1 and 7 over 2. Because the x is in the middle, I'm going to shade in the middle. On this side, at the 1, I just have a less than symbol. So now we have to close off that shading. So now that I have a 1 down here with a less than symbol, I'm going to put parentheses. And on the other side, I'm going to put a bracket. Remember, you can always go back and use that chart from above. So now that I have my interval notation answer, now that I have my graph, I have my interval notation answer. The interval notation answer is going to be parentheses 1. We put a comma for the shading. You're shading to 7 over 2, and 7 over 2 has a bracket. So this is your interval notation answer. And this is the graph. All right. I want you to try number 13, but we need to change number 13. So change number 13, well, this is 1 plus 2x, because you're not going to have to do any like flipping. So try that problem. All right, so again, you want to isolate x and get x by itself. The first thing you want to do is get rid of that 3. That whole middle part is divided by 3. Well, what's the opposite of dividing by 3? The opposite of dividing by 3 is multiplying by 3. So if I multiply 3 in the middle, I have to multiply 3 on both sides here also. The purpose of multiplying by 3 is because now the 3's cancel out. I have 1 plus 2x. Put my symbols on both sides. 3 times negative 2 is negative 6. 3 times 3 is 9. And now I need to get x by itself. So I'm going to subtract 1 from all 3 places. Bring down my little symbols. Negative 6 minus 1 is negative 7. All right, this is 2x. Less than or equal to 9 minus 1 is 8. To get x by itself, now I need to divide everything by 2. All 3 places. So I get negative 7 over 2, less than or equal to x, less than or equal to 4. Again, this is your set builder notation answer. All right, all you have to do is just type in what you have in pink. Then you come right over here and you graph it. All right, if I go to my graph, draw my little number line, the only 2 numbers I care about is negative 7 over 2 and 4. And you're shading between the 2 numbers. Because this is less than or equal to on both sides, I'm going to put a bracket around my shading on both sides. So this is my graph. This leads me to my interval notation answer. Interval notation, again, is just a short version of your graph. So it's going to be bracket, negative 7 over 2, comma, 4, bracket. All right. So now let's look at absolute value inequalities. All right. So absolute value inequalities. So the first one we're going to look at is in this first box. It says observation 3. I remember less than. Just remember less than. An inequality. An inequality is just like number 13 and the one before, where you have the shading in between. So it's going to look something like this. So if you notice, it says if the absolute value of x is less than a number, which in this case is k, your answer is going to look like this. Right? So basically, based on the fact that I know that I have the absolute value of x is less than 4, I'm going to have an and inequality where x is going to fall between 4 and negative 4. And that's it. I mean, that's how you do an absolute value inequality, 4 and negative 4. All right, and then you put your little squiggly stuff around it. That's set builder. When it comes down to shading, you shade in between. Excuse me, y'all hear my dog. Chance, stop. All right, and then you put parentheses on both sides because they both have parentheses. Your interval notation answer would be negative 4, comma, 4. All right, the next one. What if you have an absolute value symbol and a greater than 4, greater than symbol? All right, so this is greater. All right, greater. So this is going to be an or inequality. All right, and that's or inequality looks like this, where you have the two numbers, but you're going to have the word or written in the middle. All right, and or is the union symbol. So your or inequality looks like this. So absolute value of x greater than 4. This is going to be x is less than negative 4. So it's less than the negative number. Or x is greater than 4. So it looks like this. When you graph it, you have negative 4 and 4. You shade to the left of negative 4. So this is less than negative 4. So you shade all the way down here to this arrow. What does this arrow represent? This arrow is negative infinity. It's a less than negative 4. So I put parentheses this way. Remember, there's a parentheses around infinity also. And then you have to shade x is greater than 4. So I shade to the right. Put my little arrow. Parentheses because I have a less than symbol on both sides. Remember, down this side, this is infinity. So when it comes down to interval notation, the interval notation would be parentheses, negative infinity to 4. Because you have two separate pieces, you have this word or. Well, in interval notation, we use a union symbol like we did in the beginning of the lesson. And then it goes from 4 to infinity. All right, so now let's look at some problems where you have to do more work, a little bit more work, but it's still absolute value inequalities. All right, so for example 16 and 17, these are going to be the only two or the last two that we do. So for the first one, we have a less than or equal to symbol. So this is less than. So remember, the less than is going to be an and inequality. So your answer is going to fall between two numbers. So it's going to look something like, your final answer is going to look like observation 3, all right, in this box here, the first box. So what I can do is, to solve this, I'm going to put x plus 8, put the same symbol they have, which is less than or equal to. I'm going to put it between 2 and negative 2. And then you solve this inequality. So subtract 8 from all three places. Negative 2 minus 8 is negative 10. All right, less than or equal to x. Less than or equal to 2 minus 8 is negative 6. Put my little squiggly line. So that's the solution. That's set builder notation. The graphing, remember the graphing? You're just going to shade in between negative 10 and negative 6. So negative 10, negative 6. You're shading between the two. Because on both sides they have a less than or equal to, you're going to put brackets around your shading. Which leads me to my interval notation solution, which is bracket negative 10, parentheses, no, not parentheses, but comma goes for the shading, -6 bracket. All right, and the last one, number 17. This is a greater than or equal to symbol. So when you have an absolute value and you're dealing with a greater than or equal to symbol, your final answer is going to be an or inequality, two separate pieces. So you take the 6x plus 2, and on this side you make it less than or equal to the negative number, or 6x plus 2 is greater than or equal to the positive number. That's how you set up your inequality. So it's just like they did here, greater than k or less than negative k. All right, so the less than is negative and the greater than goes with the positive number. And then you solve both inequalities. Subtract 2 from both sides. So 6x is less than or equal to -4. Divide both sides by 6. And x is less than or equal to -2/3. You don't divide, you don't flip the symbol because you're not dividing by a negative. So some students think, oh, I see -4, I need to flip the symbol. No. If you were dividing by a -6, then you would flip the symbol. But in this case, we don't have to. So x is less than or equal to -2/3. Then I'm going to subtract 2 from both sides. 6x is greater than or equal to 2 minus 2 is 0. Divide both sides by 6. X is greater than or equal to 0. So you have two separate pieces. All right. So you have that x is less than or equal to -2/3, or x is greater than or equal to 0. All right. So if you wanted to put your set builder notation, it will look like this. When it comes down to graphing, because you have two separate little inequalities, you're going to have two separate pieces that are going to be shaded. So the negative number comes down here, -2/3, 0. Those are the only two numbers you care about. You shade out here. To the left, this arrow represents negative infinity. You always have a parentheses around your infinities. Less than or equal to is a bracket. When I get on the other side at 0, I have to shade all the way down to this arrow, which is positive infinity. Parentheses, and use a bracket at 0. So your answer would be negative infinity, comma, for the shading, to -2/3, bracket. And the or, we use the union symbol. So in my math lab, you just choose the union symbol, and then it goes from 0 to infinity. All right, and this will be your interval notation answer. And that's it.